Hello class, this is a video tutorial on adding and subtracting with scientific notation. So when adding or subtracting numbers, the place value of each digit is simply added or subtracted. When written in regular notation, we can see that the place values are heavily affected by the powers of 10. What I'm trying to get across here is it feels like we could simply line these values up by the decimal and add them. So doing this one in red, it feels like this value just simply becomes 4.54 times 10 to the power of, perhaps we might add them. It feels like this is what we might do. However, this is very much incorrect. And we can see why when we do these values in expanded notation, or normal notation, so to speak, to the power of 5. That means we're moving 5 spaces to the right, so 1, 2, 3, 4, 5. And we can count 3 extra zeros, 1, 2, 3. So this becomes 0, 0, 0, 4, 1, 3. So the first number becomes 314,000. We do the same thing with this value, moving it 3 spaces to its right. So 1, 2, 3, and we can count 2 extra zeros appearing. So 0, 0, then 4, 1. Now we can see by lining up the appropriate place values, when we add these, we get 0, 0, 0 plus 4 is 4, 4 plus 1 is 5, 1 plus nothing is 1, 3 plus nothing is 3. And so when we convert this back into scientific notation, we get 3.154 times 10 to the power of 5. Notice how that is drastically different from the appropriate answer. So this is the idea we're getting across. We simply can't line up our digits because these powers of 10 are not the same. Only once they are the same could we line them up and then add the decimals. So to get around this problem, we need to first adjust the powers of the smaller term. Then we can add or subtract without expanding the notation. So I'll demonstrate here. Since this value here, 10 to the power of 7, means this number is going to be bigger because we're going to move this 7 spaces, whereas this is only moving 5 spaces. So this first number remains the same because it is the larger number. But this one is to the power of 5, and we want this to the power of 7. Well, since we want to move this 2 more spaces to the left, because we want to increase this by, we want to increase this by 2, we're going to add on 2 more spaces. So 1, 2, and it becomes 0.034. Okay, so this will become plus 0.034 times 10 to the power of 7. So 2 spaces, 1, 2. So 0.034. Now, since they are both to the power of 7, we can line this decimal up underneath this one. So we're now going to add 0.034 times 10 to the power of 7. Since they are both the same power, we're confident that when we add the digits, it is the appropriate place value. I'm going to put an imaginary 0 behind the 5 because it's going to be 0 plus 4 gives us 4. 5 plus 3 gives us 8. 1 plus 0 is 1. The decimal goes here. 2 plus 0 is 2. times 10 to the power of 7. So that is the appropriate addition of these two values in scientific notation. And that is the general idea that we are working with. We have to adjust the smaller term to match the power of the larger term. So you can pause at any time and give this a go. And let's see how we can go with these next ones. So here we go. First, let's recognize which of these are smaller. So as you can see, 10 to the power of negative 10 is actually smaller, and this is larger. So we want to make this match 10 to the power of 9. Well, a little bit tricky here. What you can do is go the long route and imagine with me here. Negative 10 means we're moving this to the left. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8. Oh, a bit too large there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if I now want to move this 9 instead of 10, it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So notice how the decimal will stop here. 0.584 times 10 to the power of 9. So this will become 0.584 times 10 to the power of negative 9. Now this matches this other value, 2.63 times 10 to the power of negative 9. Now that they are both the same powers of 10, we can line this decimal up, 2.63. I'm going to include another 0 so that we can appropriately add this. So now we just add vertically. 4 plus 0, 4. 8 plus 3 is 11. 1, carry the 1. This becomes 6 plus 6 gives us 12. Carry the 1. 1 plus 2 gives us the 3. And the decimal is carried with it. And the power that we had for both remains the same. So the appropriate subtraction of this is this value here. So this is the answer. All right, so I hope that's giving you a quick insight in these first two examples. You can pause and try these next two right after this. Hope to see you then when we do these next two examples. Hope to see you then. Best of luck.